Today's presentation will be about the latest developments of Morphing and Optimization version 25. Following the redesigned user interface of version 25, the Morph functionalities have been divided into two ribbons, the Direct Morph and the Box Morph ribbons. Each ribbon contains the relevant discipline-focused functionalities that ensure enhanced efficiency, coherence, and streamline operations. For this purpose, the tools for reinforcements and bulkheads are now related and now can be accessed from the Direct Morph ribbon under the Design menu. Continuing in the Direct Morph ribbon, the interface of the PM member function has been updated. It now enables the step-by-step creation of new members easily and effectively. In the Box Morphing ribbon, there is a unification of functionalities, making everything more organized and intuitively structured, as you can see in the points function, for example. Now let's move on to the new functionalities. A robust and versatile morphing algorithm has been designed to facilitate the morphing of fillet regions both within cell and solid meshes. This algorithm enables the modification of these fillet regions by parametrically adjusting the radius of the fillet, thereby providing precise control over the geometric transformation applied to the mesh. Continuing, the detection and treatment of morph contacts is now integrated as a built-in feature within the morphing functions. This integration into the DFM functionality enables the prevention of intersections by either surrounding elements or freezing them. Continuing, for the modification and in the handling of 2D ribs, an interactive functionality has been developed for the repositioning and modification of the shape of two-dimensional ribs. This feature allows the precise adjustments to the position and form of the 2D ribs, enabling control and flexibility in design modifications as demonstrated in this example. Moving on to the latest developments in the optimization tool. A new optimization algorithm is implemented called Sequential Quadratic Programming, or SQP. This is a classical and powerful algorithm of nonlinear optimization, and it is especially suited for constrained single-objective optimization studies. SQP belongs to the local search group of optimization methods that information about the gradient of the objective function and the constraints to decide how to move around the design space. Typically, such methods start from an initial guess, or initial design point, and move around the design space to reach a local minimum. Responses that are going to be used in parametric optimization cases can now be bind, thus forming expressions for the constraints that will be used in the optimization study. Regarding the RSM, a few more response surface model algorithms have been added in the tool. So far, we had the options of machine learning in Crygen. Now, with version 25, four more well-known algorithms have been added that utilize the ML Toolkit add-on software. This development will allow for more freedom in testing in cases of response, surface model assisted optimization. Additionally, this functionality is now also available in working directory mode. Now we will move on to a short demonstration of these changes. We will start with the fillet function. The fillet function can be found in the Direct Morph menu of Direct Morph ribbon. It allows us to select existing fillet regions similarly to other morphing functions. For this example, we have set up a few sets in order to make the selection of the respective areas easier for the demonstration. We start with the definition of the affiliate region. We move to the definition of the transition area. And depending on our case, we may need to adjust the fixed areas where the modification of the fillet regions will stop. We can either select the automatically defined ones as you can see here, or we can even define new ones by selecting the second option right here. Let's say, for example, that we want to freeze the modification of this round hole, maintaining the shape. Now, regarding the modification of the fillet area, we have three options available. One that allows us to scale the radius of the selected fillet, another one to offset it by a specific number, and also to set a specific target radius to our fillet. For example, we select the first option. You may see that as we change the value of the scale, the fillet is scaled as well. A similar modification can be applied using the offset action. You can also preview the modification by enabling the respective flag. By selecting target radius, we set the value to the fillet area and that changes the region. Similar to other morph-related functions, we have the ability to improve the mesh flow after the application of our modification, and we can also save the modification as a morph parameter of the type fillet, in which case we can later use it to parameterize it along with other parameters, or we can even use it in optimization task. Let's suppose that we have a parameter that we want to morph it according to a specific value. Since this is very close to another part, it will cause some intersections after morphing it beyond the specific value. For that purpose, the Morph Contacts tool was developed. In previous versions, it allows us to define specific areas that would perform some corrective actions, in order to ensure that we have no intersections, especially in optimization cases. In version 25, this functionality has been integrated also within the DFM function. So if we open the DFM definition, you can see that at the bottom, apart from constraints, we also have the ability to set up contacts. We have two options. The first one is the morph surroundings. This will morph the surrounding areas, pushing them out of the way to avoid the intersection. To define that, we need to select the entities either by manually selecting the areas of interest or by selecting from the whole database. For this morphing action, we can also set up some transition zones for the contact, and if we do so, we can try to morph. And as you can see, the green part is also modified as well and no intersections occur. We also get a message that notifies us when the intersection would occur. The other functionality that is available in the form of contacts is the rigid surroundings, in which case when the intersection would occur, we have the ability to be notified with a warning or even stop the morphing action of the surrounding area completely. Continuing for 2D ribs, we have this part that has some 2D ribs, and we will see the new function that enables us to modify those ribs. This function can be found in the retopology ribbon of the mesh, named Modify Ribs. And what this requires from the user is to have the 2D ribs already recognized by the feature manager, and also have a draw vector set up. Going to the Modify Ribs function, we have some options. The modifications that apply is to the position of the rib in our model to the height of the rib. We can also apply the bending to change its shape. To modify the position, we simply need to select a specific rib and drag and drop it according to our needs. We can also enable the snap on perimeters or disable it, in which case the rib will not snap on the surrounding areas. After we accept the modification, we have the 2D rib that is repositioned. You will notice that the 2D rib is not welded to the surrounding areas. For that reason, we simply need to use an existing function called welding FA. So far, this has not been integrated in the ribs function, but it is in our plans for the future. This function can be found in the geometry ribbon under the intersect and welding FA. In this case, we need to select the entities that we want to weld. The new rib is welded to the surrounding mesh. Apart from the reposition of the ribs, we can modify the height of the rib at a specific point, or we can by dragging and dropping the edge. Or we can select the edge and then select a specific point, in which case we can modify the height on a specific corner of this rib. We can even select a corner point and modify the surrounding areas altogether. Last but not least, we can also apply some bending to our rib to change its shape. Now moving on to the optimization tool. First of all, the optimization tool can be found in this section right here on the left side. If it is not visible, you simply need to click on the Lists button and enable it. The first new addition of the optimization tool in version 25 is the ability to create new response surface models using one of the available algorithms from the ML Toolkit. Available are the ordinary list squares, extreme gradient, and so on. There is also the ability to select the auto algorithm, the auto option. The auto option is the old machine learning algorithm, and all these functionalities are available in working directory mode. The ML Toolkit that provides these algorithms is an add-on software that is required in order to use any of the algorithms. If the required ML license credits are available, the AutoML function can be used as well. In the Optimizer tab, you can see the new optimization algorithm that has been implemented called SQP. This is the sequential quadratic programming optimization algorithm. When we create a new optimization study, we can use the Constraints Edit button in order to create expressions between the responses that will be used as constraints. For example, we want the sum of the two stresses to be below a specific limit. We can add that and proceed with the optimization. Thank you for your attention.